talk about the topic. So we're talking about the topic of functions. So that's kind of what this whole unit is about. And the first two lessons were mainly spent on what we would call straight line functions. Let me just make it slightly thicker. So straight line functions. And in the first lesson, we spent a lot of time like finding things about straight lines. So we found out stuff, or finding things. We found the equation, we found the x-intercept, we found the y-intercept. And these are all important ideas for studying functions. And then the last lesson, we were actually drawing or sketching straight line graphs. And we used a lot of the information that we learned about in lesson 1, and that helped us in lesson 2 to draw or sketch graphs. Okay, so that was the basically, and some of the important words would be like x-intercept, y-intercept. It would be an intersection point. We learned how to find intersection points. We learned how to find gradients. So these are all important ideas. Now today, we are going to start looking at something called quadratic functions. And a lot of the ideas for quadratic functions link back to the earlier straight line functions. So you're still going to have to be able to find the y-intercept, the x-intercept, and these are going to be important ideas, and we're going to figure them out as we go. But before we do that, I want to ask you, what is the most basic straight line? What is the most basic quadratic function that you guys know about? So maybe if you can put your hand up and tell me, or pop it in the chat. What's the simplest straight line? Sort of straight line. What's the simplest quadratic function that's possible? Pop it in the chat. Or put your hand up and I will gladly so the simplest straight line function that I know about is something called, sorry, I keep saying straight line. My brain is programmed. The simplest quadratic function, or simplest parabola, is y equals x squared. Okay. Now, if you want to think about what a parabola like y equals x squared looks like, what type of shape comes to mind? So what does the parabola y equals x squared, what does that look like? A smiley face, exactly. So when we talk about quadratic functions or parabolas, the most basic shape is to think of a smiley face. And that will always happen as long as the number in front of the x squared is a positive. Now, the other thing is, I've said a quadratic function is y equals x squared. What makes a quadratic function different to a straight line function? If you just look at it, and also if you look at the equation, what's different? And I'd love to either have someone raise their hand and tell me, or put it in the chat. What's different about a quadratic function? Any ideas? What makes it different? So the one thing that I can see is that a quadratic function has a power of 2. So there's a variable that's raised to the power of 2. So that's one really important thing. The other thing that's important about a quadratic function is it's got curvature. It hasn't got straight lines. It's curved. Okay. Now, what about if I said to you, what does y equals minus x squared look like? How would you describe that in words? You pop it in the chat. What does it mean if I go y equals, what does that remind you of? It's a sad face, yes. So y equals minus x squared will look like that. It's a sad face. So the number in front of the x squared actually makes a parabola happy or sad. And that's really important. So something to do, this is going to come up a lot today. The number in front of the x squared, in this case, it's going to be 1. In this case, it's minus 1. If it's a positive number, it's happy. If it's a negative number, it's sad. Okay. What if I gave you the equation y equals 3x squared? Would that be happy or sad? Would it be more happy or more sad? How would that look for you if you were drawing that on the Cartesian plane? Okay, so y equals 3x squared is going to be what? It's going to be more happy. It's going to be going up. It's almost like its cheeks are going to be like forced into a massive smile. Okay, so what I want to point out is that this number in front of the x squared is really, really important. Yeah. Okay, now one more thing before we really get going. What if I said to you that instead of being y equals x squared, it's now equal to y equals x squared minus 3. It's still a happy graph, but something happened to this happy graph. What happened to it? Who can tell me? I know it's a happy graph because it's y equals x squared. It shifts. How does it shift? Can you tell me more about how it shifts? Did the happy face get closer to the ground, or did it get closer to the sky? Upward? No, I don't think it went upwards. I think it actually went downwards. Okay, now how would we be able to tell this? Well, one of the ways is we know that the y-intercept. What's the y-intercept going to be of this parabola? When we want to find the y-intercept, we know what to do from straight lines. We make x equal 0, don't we? So if we make x equal to 0, we are going to get the y-intercept is minus 3. So it's going to be down here. And then, because it's a happy graph, it's going to be sloping up like that. So we know the happy graph is still happy. It's just been shifted down by 3 units because of that minus 3. So what are these 2 blue dots over here called for this parabola? Just before we really get going, what would we call those 2 blue dots? If anybody's feeling brave, just put your hand up and you can tell me audibly, chop chop. Otherwise, pop it in the chat. What are those 2 for this parabola? How would you describe those 2 blue dots? They're called the x-intercepts. Yeah, they're the x-intercepts. And if you are finding the x-intercept, what was the rule that we used when we did straight lines? What do we have to do to find x-intercepts? Can you remember? You make y 0. So essentially, if we wanted to find what those 2 x-intercepts were, we would have to solve this equation. And if we solve that equation, we would then find our x-intercepts. So what is tonight going to be about? Tonight's going to be about learning how to basically draw parabolas. In order to draw parabolas or quadratic equations, you need to be able to find a couple of things. You need to be able to find the x-intercepts and the y-intercepts. But you need to be able to find one more other special thing. If I look at my parabola, there's one important point that you still need to find I haven't spoken about. Can anybody tell me what that would be? What's that point called? It almost looks like the top of a roller coaster ride or something. It's the turning point. Yes. So when we talk about quadratic functions or parabolas, not only do we need to know about the x and y intercepts, we need to know if they're happy or sad, and we also need to know about the turning point. Now, how to figure out the turning point, I will come to later in the lesson, but I just want to make sure you've all got those basic ideas. Now, what we're going to do is we're going to start with practicing solving quadratic equations, because in order to find x-intercepts quickly, you need to be able to solve equations like 0 equals x squared minus 3. And to do that, I would recommend using something called the formula. So let us look and a little bit of practice about quadratic equations. So I am going to give you this equation, and the reason we're practicing this is often when you have to draw a parabola, you have to solve one of these to find the x-intercepts. Imagine if this was the parabola y equals x squared minus 5x minus 3. And I said, find the x-intercepts. You would then come along and make y 0. So we're practicing this bit. Now, the quickest way to solve a quadratic equation is to use this formula called the quadratic formula. And what I do to figure this out is I always start by working out this thing inside the square root. That thing is called delta. So what I do is I work that out first, and then I use my formula. But over to you guys. I want to see, can you solve for the x values that make this true? And I'm going to give you about a minute and a half to do that. And then while you're working, I will give you some hints. Or if you have any questions, raise your hand. Okay. Mandisa, what about domain and range? We will talk about domain and range in later lessons. So today, I just want to check that you can all find the x-intercepts, basically easily. And in order to do that, I need to make sure you can solve quadratic equations. So over to you guys. See if you can find the x values that make this true. My tip is to use the formula. You could use maybe something else, but the formula is like, it's like the Swiss Army knife. It just gets the job done. You can use your calculator with setup mode 5. That's also fine. Yeah. It's just that sometimes the question requires you to show some working. And so that's what I'm going to do now. Yeah. So I got a delta value of 37, but that still doesn't give me my answers. What are my final answers going to be? You still need to do some work. So remember, in the quadratic formula, you have both a positive and negative root. And was it 2 times? Oh, wait, I must have a negative root here. So what are my final answers? So 5.54. What is the other one going to be? So I get minus 0.54. So just to point this out, so guys, it depends on how the question, sometimes if you've got a quicker way of doing this, so I think it depends on your school as to whether or not you can, like it depends on how the question is phrased. Sometimes you have to show some working. You don't always have to show this much working. I'm showing you the whole step, but you do need to reliably get to this answer over here. And so give us a thumbs up if you felt okay with that one. Give us a thumbs down if you feel unsure. Because if you want to get your easy marks in the section, you must be good with quadratic equations. Okay. So that was just the first one. We're going to do three.
I'm also here if you're feeling a little bit lost. I'm here to help.
So again, I'm assuming that you have some exposure to the quadratic formula. Just to run through what I did here, my step one was to work out delta. Now, delta required something that is important is when the question started, it's in standard form. And so I know that A is equal to 1, B is equal to -5, and C is equal to -3. And what I did was I then substituted those values first to help me find the delta value, and then I subbed it in to the other part. So I was basically just applying that formula. Now, I do think we need some more practice, but just to warn you, you need to have your equation in standard form. So take a screenshot if you need to take a screenshot now, and we're going to do another example to get going. So take a screenshot if you need to. And let's go on to the next one. Can you solve that quadratic equation for me? Over to you guys. So I want you to solve, you're going to get potentially two values, although sometimes you may not, but can you solve for the value of t that makes that quadratic equation work? And while you're working on that, I will just put the formula up. This is on your formula sheet. And what I often start by doing is just working out what delta is. Actually, you know what? I would start by writing down what A is, what B is, and what C is. So start by writing out those. Okay, and then once you've got your answers, you can pop them in the chat. Four times A times. So what do you get? I'm saying x's. I shouldn't really say x. I should say t. So I get -1 plus minus . If you want at this point, you can just use your calculator. Sometimes just using your calculator at this last bit is helpful. So the square root of 49 is just going to be 7. I get 1 as the one answer. What do you get as the other one? Yeah, there's some students who have raised their hands. So, Hlolo, do you want to ask a question? I try to unmute you, and then Rachel, after that, I'll come to you? What are you getting for your answer there? Or what do you want to ask a question about? Any questions? I'm not seeing. So I get -4/3 as the one answer, and I get 1 as the other answer. So just to show you how I got the second one, I had -1, and then I took away 7. So I got -8, and then it's -8 divided by 6, because at the bottom here, it's 2 times 3. Because in our formula, we have 2a, and we know that a's value is 3. So you should have got those 2 answers. Okay. Now, I'm going to leave this up because I know some students want to ask questions. I want to challenge you guys to solve this one, but I'm going to give you a warning. When you solve this quadratic equation, it's not in standard form. And so you're going to have to first do some algebra to get it into standard form. But I'm going to leave you to figure this one out. And I want you to find me 2 values of p that make it true. And then while you're working on that, I'm going to ask for students who are feeling a bit confused to raise their hands. Okay, Ritabile, coming to you. How can I help? Hi, Ritabile. Can you hear me, Ritabile? Otherwise, Dineo, I'm going to unmute you. Who's that speaking? Who's that speaking? Okay.
Hello, sir.
Hi, who's speaking?
It's Kamo. It's written Dineo there, but that's my mom's name. She signed up with her name, but my name is Kamo.
Kano.
Yeah.
What's your question? Is it about the previous one we're doing now?
Yeah, it's about the previous one.
Okay.
I wanted to ask the 3t squared. Do we just leave the square when subbing in, or we don't sub in the square?
So when we use the quadratic formula, the first step is to be familiar with the formula. Are you familiar with the formula?
Yeah.
Okay, so that's step 1. Step 2 is this in the standard form? It is in standard form, so that's all good. Then what I did is the number in front of the t squared is a, the number in front of the t is going to be b, and the number in the constant term is c. So when you actually sub this in, you're right, you almost ignore the t squared. The magic of the formula is taking care of that for you.
Does that
kind of make sense? Now, that's actually linked to something called completing the square, but we're not worrying about that today. The honest truth is once you apply this formula well, and you get the right answers, you've got essentially what I'm teaching you is how to find the x-intercepts for later in the lesson.
Okay, I understand now. Thank you.
Pleasure. Okay, so while I just want to show you guys how to get it into standard form, and then I'm going to come back and take more questions. So in the second example, we would get 4p squared plus 2p, and then we'd have to bring the plus 2 from the one side across to this side. And so I want everyone, if you didn't get to that step, I've helped you. But now you have to solve this quadratic equation, 4p squared plus 2p minus 2 equals 0. And I want to see if you can get the final answer. And then I'm going to answer some questions. Let's go to Rachel. Rachel, do you have a question? I'm trying to unmute Rachel, if you can unmute. Can you hear me? Hello? How can I help? Hi, how can I help? All right, I think the sound is a bit bad there. And if you want to maybe mute there, Yolanda, and then we'll come back to that. Okay, so in the second question, the next step that is quite important is going to be figuring out, I think it's really important to find your A, B, and C value. So you get A is 4, you get B is 2, and you get C is -2. Now, you know that you have to apply this big formula, but along the way in that formula, you have to figure out this delta thing at some point. And delta is just B squared minus 4AC. So I will write this up for you. And then once you've got your answer, just pop it in the chat. So 2 squared, so B squared, so it's 4 minus 4 times 4 times -2. And I get, what do we get? 4 times 4 times 2. I get 36 as my delta value. And so what are my final answers going to be? So I basically just go, P is -2 plus minus the square root. So actually, guys, I think it's actually quicker to just write this all in one thing together. And so you go 2 times A, so 2 times 4. And really what you now need to do is just work out what that is. So notice how I'm not splitting them anymore. It actually is quicker to just leave them together until the very end. And then now at the very end, what I'm going to do is I'm going to go -2. So now what's the square root of 36? It's 6. So -2 plus 6 divided by 8. And I get P is equal to 1/2. And then the next one, -2 minus 6 divided by 8, it's going to be -1. And so my two answers were 1/2 and -1. Watobe, what's your question? Let's do one more of these guys, then we're ready to move on. Last one. Hello, Watobe.
So I have a question about the quadratic formula.
Go ahead.
So is the quadratic formula used, is it one of those cases where P or X or T has to be 1?
It doesn't have to be 1. The number in front of the quadratic formula can be anything that, in this case, the 4 is the one in front. What did I miss? It doesn't have to be 1. No, it works regardless.
So actually the quadratic formula, we use it when we cannot factorize.
Yes. Okay. Now, sometimes you can factorize it, but when you're dealing with sketching graphs, it's often so reliable. I would recommend for most students, unless the factorization is super obvious, just get really good at using the formula, is my recommendation. Okay, let's do this one. And what I'm going to recommend is change it into standard form first, and then write down your ABC, and then do your steps. So over to you guys, and then I think we deserve a break. Yolanda, is there anything I need to be aware of? I know I'm pushing them a little bit late for their break, but I know.
So it's just that they're very confused with the delta. Then they need to can just use the formula as it is. They don't have to take out the delta and calculating delta. Okay,
this is it's fine. You don't have to work out the delta separately. You can just work it straight in the formula. So don't feel like you have to do what I'm doing. I'm just doing it because I think it shows the process that I'm doing. But as long as you're getting the answers reliably, you can skip some of these steps, guys. That's not a problem. Okay. So if you can sub everything into your equation in one go, I'm very weary of students making a silly mistake. That's why I think it's good to sometimes have some steps along the way, but that's their choice. So I'm going to just suggest that you need to get this into standard form first. And then you need to know those numbers. So you don't have to do the step that I'm doing with delta. I'm just working it out because it makes my life a little bit easier.
You guys are doing well, by the way. I'm really proud of all of you.
It's like today, it's almost like we're doing leg day at the gym. We need to make sure we don't always do it, but we need to make sure we've got this the skill sorted, because it's the bedrock of a lot of the stuff on functions. So what have I got? -3 plus minus square root of 25 over 2a, so 2 times 2. And what are my answers going to be? What are my final answers going to be? Okay, so I've said X. I shouldn't have said X. I should have said F. Apologies. So one of the answers is F is a half. And then what's the other one going to be? It's going to be -3 minus 5 divided by 4. And I get -2. Okay, so you may need more practice, but I think I've given you enough practice in the quadratic equation for now. And so we're going to take a brief little break. And so I want everyone to stand up and do their favorite stretch. And Yolanda is going to review your performance out of 10 for technique, enthusiasm.
Yes, guys, let's go.
Let's stand up. Let's stand up and let's stretch, because we have been working hard for almost half an hour already. Let's see it. I know it's cold in Joburg, Leletu, but you can do it.
Kelly, I see you.
Come on. We know our bodies are happier when they've, this is bringing me great joy, everyone. Oh, great joy indeed. Get that stretch on. I'm going to do the arm stretch like this. Oh,
let's go, Cheesy. I see you, girl. Tembi, I see you.
Doesn't it feel good? So Kanya, I will zoom up for the previous question. Absolutely. Does that help a little bit? Also remember this.
Let's see your head. Let's see your head tilting at least. At least move your head, man.
Yeah. Trust me, your body will thank you. Your body will thank you. Oh, that feels so good. I feel like I should leave a stretch class maybe at some point. I'm getting carried away. But,
yeah, that will be good. I also needed it.
All right, everyone. Let's do it. Brain break time. Tell me about these flowers. Let's do it. Yeah. Okay. So it's been suggested by Nokulunga that 20 is a rose or a red flower, which I think is awesome. Yeah, I would agree. And what is a blue flower going to be? So a blue is going to be 5. But now be careful, because there's 2 flowers here for the yellow one. So what is one yellow flower going to be? Rachel, I agree with you. I think a yellow is a 1. So that's so there's the 2 1s together make 2. 5 minus 2 is 3. Now what's the final value going to be then? Okay, be careful because this has to only be 1. This isn't 11. So each of these are 1 by themselves. Together they give you 2. And now you need to use BODMAS to say which of these gets done first. So I think I agree with Anele and Kaklejo. The final answer is 101.
Well done, guys.
Fantastic. Okay. Brain break over. I hope you've done the stretch because then your brain will be ready for the second part of the lesson. Sarah, question. What's your question?
So I would like to ask at the bottom one for the brain break. How come the flower would you still get the same answer if that flower on the bottom has 4 leaves and the rest of them have 5?
Oh, I think you have spotted something. Okay, I'm just gonna recognize that Sarah's made an important observation that there's 4 leaves here and everything else was 5. All I'm going to say is in that case, both 81 and 101 would be correct. Okay, but I like your eagle eye, Sarah. I'm gonna chalk that one. I'm gonna say there's 2 correct answers on the
That was a very good one. I couldn't even see that.
Okay. So what I'm gonna do now in the last part of this lesson, guys, is I'm gonna teach you the process for drawing a parabola. Now, I had intended to start with grade 10 parabolas, but I actually think you're ready for the whole experience of drawing a grade 11 parabola. And the only difference between a grade 10, we'll see if you can spot the difference. Let's see if you can spot the difference. I'll put these together. So these are the grade 10 ones. And we're actually going to start with a grade 11 one, which is this one over here. But I'd love to see, can you spot the difference between grade 10 and the grade 11 parabolas? And I'd love for someone to tell me kind of what the difference is. Sarah, yeah.
Also, I don't have a question.
Oh, you don't have a question? Yeah. Rachel? Hello? So does anybody notice the difference between, I'm going to start by teaching you how to draw this one here. There is a relationship. The reason I'm going to start with this one is this process will also work for the grade 10 one. But I want you to look at what's different between the grade 10 one and the grade 11 parabola. They're both quadratic equations. They both got an x squared, but there's one subtle difference. Amulkelani.
So I think for the grade 11, it's in the form of A, B, C, and it's h of x equals to the equation.
Yeah.
I think.
Yeah, you're on the right track. You've named, definitely it's got a different notation, h of x, but you could write this as y equals x squared minus 6x plus 9. That would still be a parabola. What's the biggest difference for this one compared to all the others? So you're very close. Has anybody else got an idea? Or maybe put it in the chat. Oh, sorry, my thing just took off. Standard form. Can you see, what about this minus 6x? Can you guys see that the grade 10 ones don't have the linear term or the term with a variable with the power of 1? Okay, so the difference between grade 10 and grade 11 parabolas, it has 3 terms. Yes, Susanna? Okay, so in grade 10, all of your parabolas, they are stuck on the y-axis. So for example, let's say x squared minus 3. You know that its turning point will always be the y-intercept. So in the case of this one over here, y equals x squared minus 3, it's a happy one. Now I haven't worked out my x-intercepts yet, but I know that the parabola is stuck on the y-axis, and its turning point will always be the y-intercept. Now, what happens in grade 11, and this is what I'm going to teach you now, is your parabola is freed. It's freed not only to move up or down, it's also freed to move left and right. So now for the first time, you can have a parabola that looks like this. And what you notice is that its turning point is no longer on the y-axis. We also say that a parabola, and I haven't spoken about this, it has an axis of symmetry. And the axis of symmetry will always be on the turning point. Okay, so this is the difference between grade 10 and 11. However, the method I'm going to teach you now, it will still work for grade 10. It's just got a little something extra to handle this parabola almost being able to move left and right. Essentially, grade 11 parabolas can move left and right. Okay, so let's start with this. So here is the recipe for doing this. Step 1, is it happy or sad? Okay, so I want you in the chat, tell me, is this grade 11 parabola, is it happy or sad? Tell me, guys, has it had a good life or is it unhappy about life? Okay, how do I know it's happy? I looked at the number in front of the x squared, which is 1. So I draw myself a little smiley face to tell me the shape is happy. Okay, second step, I always need to find the y-intercept. How do I find my y-intercept? What's the important step I need to do? We used it in straight lines. Pop it in the chat, guys. Make x equal to 0. Exactly. Now, if I look at my grade 11 parabola, if I make x 0, and I know I've got h of x, but we can rewrite this as y equals x squared minus 6x plus 9. What is the y-intercept going to be for this parabola? So the y-intercept is going to be 9. And so, guys, this is what I love. The skills we learned for straight lines are helping us in parabolas. Okay, next step. How do I find the x-intercept? I simply make y equal to 0. So how do I do that? I go 0 equals x squared minus 6x plus 9. Now, can you see that's a quadratic equation that we had to learn to solve earlier on? Now, some of you will be able to factorize this. It's not wrong. You can see that you could factorize this, but I would love you to quickly, either by factorization or by the formula, work out the x-intercepts for me. Do that for me, chop chop. And then pop it in the chat. And it's, I know some of you will say, I can just factorize this quickly. That's fine. It's not wrong. You can do it like that. Or you can do it using the formula. And I want you to get the answers for me now. So I'll go. And all I'm going to do is I'm going to underline my A value, my B value, my C value. Now you'll see something rather interesting. The delta is 0, which is actually super awesome. So did you guys get the fact that that x is equal to 3? Everyone happy? Okay, fantastic. Now, both ways, if you've done the factorizing or you did the formula, both will work fine. Okay, now, Here is step 4, and this is something a little bit more interesting. Step 4 is finding the axis of symmetry. And I'm going to give you a special formula to work this out. The formula that you use is going to be x is minus b over 2a. So minus b, I want you to work out, think of the original equation and work out for me the axis of symmetry. And you're going to use the formula minus b over 2a. And then I want you to pop that in the chat. Now, again, I'm just telling you in my wisdom as a math teacher that I know that this will work. So minus 6 over 2 times 1. And so we're going to get 3 in this scenario. Okay, fantastic. Now, the last part of this 5-step process is to find the full turning point. And in order to find the full turning point, we take the axis of symmetry number and we plug it back into the original. So basically, we know the x value of the turning point. I want you to put this back into the original and see what you get. So go back to the very beginning and you put 3 in there. What is your final answer going to be? So you take 3 and you put it back into the original equation. So 3 squared is 9 minus 6 times 3. So that's minus 9 and it's 0. Okay, so guys, this is what you've got. You've got 5 important pieces of information and you are now ready to draw your parabola. So let us take these pieces of information. Now, I know it's a little bit more work than before, but it's really the same process. So what do? I draw a Cartesian plane. And what I'm going to do is I'm going to make dots for all the important points. So my y-intercept, that is going to be 1 dot up here. So let's make it up here. I'm not going to label it yet. Then what I'm actually, you know what I'm going to do? I'm going to label my second point 3 naught, which is over here. Okay, so I've got my 2 dots here. Now, the other thing with a parabola is we actually draw a dotted line which stands as our axis of symmetry. And what was my axis of symmetry? It was just going to be x is equal to 3. Okay, so now I have to actually fit my graph through these 2 points. Have I used up all my points? I've used up the 9, I've used up the 3. So my parabola is just going to look like that. Now, what's the final step I need to do, guys? What have I not done that I always have to do at straight lines at the very end? Who can tell me what's the step that I'm missing? I haven't done something that's important. You have to name the graph, and I haven't labeled my intercepts. So I need to label that this is 0, 9, and I need to label that this is 3, 0. And what was the name of the function? It was the function h. Now, we need to do this a couple of times. You can't just do it once. But what I want to say to you is I've given you a 5-step plan. The 5-step plan, the first 3, well, the x-intercept and the y-intercept are an absolute given. But with parabolas, you have to say, is it happy or sad? And then 4 and 5 is a little bit new. And 4 and 5, what they do is they work together to give me this thing called the turning point. And the turning point is really important when sketching parabolas. And the other thing you'll notice is I've drawn in a dotted line for the axis of symmetry. Now I want to squeeze in, I don't know if it's going to be time tonight. In fact, we'll only do the first part of this tonight, and then we're going to call it a day. And the next lesson, we're going to start this process and do a whole lesson on this drawing. But let's just start the next question. We've got about 5 minutes or so that we can still use. And just take a screenshot of this if you need to do that now. Okay, take a moment to do that. And then we're going to take our 5-step process out for a spin. Give me a thumbs up if you're ready to roll. Okay. Somewhere in between. Okay. Well, let's just try our 5-step process. So let's go to, I want you to draw this parabola for me. Now, it's a little bit hazy. Y equals x squared minus 6x plus 8. I'm going to draw the 5 steps for you. So first of all, do the first 3 steps for me. In fact, why don't we just do all 5? See if you can do the 5 steps, but first see if you can do the first 3 and then do the last 2. We're not going to draw the graph today. We're just going to get our essential information. So over to you guys. Let's do it.
Last question of the day, guys. Let's do this. Make sure you understand.
I'm always amazed how quickly it goes. The time goes so fast in terms of just explaining these multi-step processes.
Yeah, it does. It's just
Okay, so step 1 is happy. This is a happy parabola. We are pleased to meet it. It's pleased to meet us. Now I want to know, what is the y-intercept? What is the x-intercept? Now, Rachel, you almost notice a little pattern, don't you? Hey, the y-intercept is, if it's in standard form, you basically can read it off the graph. It's chop chop. Totally. Y-intercept is 8. For the x-intercept, remember, we're going to have to solve this equation. We must make y equal to 0. Now, for those who feel comfortable factorizing, it's not wrong to factorize. In fact, in this case, I think the factorization is quite easy. But also, the formula will always work. So either of these will give you the right answer here. I'll even do both. For those who like me writing it straight into the equation, maybe I'll just do it all in one step for you. This feels like a lot of things. But if you like multitasking, then I'm sure we can. Okay, so once you have got your x-intercepts as 4 and 2, I'm going to ask you to pause, because in the next lesson, we are going to continue with this example. For those who want to work on this before the next lesson, I'll just remind you what the magic formula is for the axis of symmetry. And we will start the next lesson with this, but x would be minus b over 2a. And then the last one would be turning point. But if you have got your x-intercept as 4 or 2, then we're going to stop for today. Okay. I'm not going to go any further than that. I feel like otherwise we're trying to squeeze too much in one lesson. So thank you everyone for today. I do know that this is quite a lot for one lesson. And so we do need to practice this for a whole lesson in the next lesson to get this process absolutely. But yeah, let's do the poll for now, and then carry on Wednesday. Best of luck with all those exams. And I hope everything goes well with you across the week until I see you on Wednesday. Cool, cool.
As we use both the x-intercept, we will use both because we're drawing a parabola. Yeah.
So we will definitely use both values, and I'll explain in the next lesson how that would work. Definitely, yeah.